everyone. How are you doing today? We made it. It's after lunch. Thanks for participating in our tasting today. We sort of had to make some last minute changes. So I appreciate you guys going through the mouthfeel with us. So today I'm going to sort of talk to you guys about barrels and about aging with wood. We're going to start with the history of barrels, and then we're going to kind of segue into chemistry of oak and some other alternative woods that we've been looking at and that have also been already studied. So I'm really excited to talk to you guys today about this because I think there's a lot of opportunity, especially in our region where we sort of have this spirit of innovation and experimentation. Because I think there's a lot of opportunity to experiment more with aging of woods and also adjunct wood products. Oh, oh yeah. Can you guys pass your tasting sheets to the side? Sorry. All right, here we go. All right, here we go. Make sure I'm talking to the mic here. So like I said, first we're going to talk about the history of barrels. This photo is not really that important. I just thought it was interesting. This is from a museum in Colmar. And as you can see, these barrels have a lot of decorative work, and one of them has a lock on it. The barrel in the middle is actually from 1767, and it's a commemorative barrel for the reign of Louis XV. So it's just kind of interesting, and you'll kind of see through the talk the place that barrels have had throughout history in culture and our civilization. So from economics to art to food. And we're going to kind of touch on that all a little today. All right. So going way back, barrels were originally basically a unit for commerce. So the first thing that basically was used for transporting grain, olive oil, wine, grapes, were amphoras. They were ceramic. They were super awkward, as you can see from the shape of them. And they didn't transport well because they were fragile and they're also really heavy. So it was okay to do those on ships. Not too bad, but when you went across country, it was even more awkward because you had to transfer the contents of those to different vessels to basically put them on like donkeys or horses. So barrels were actually the replacement for those. And so you could move them, you could roll them, you could stack them, and it was a lot easier to sling those on the sides of animals. So basically they replaced amphoras, and that's sort of where we started with barrels in our civilization. They were a unit to basically help us transport goods and sell them. So you may or may not know this, but oak is sort of a more recent focus in barrels, especially with its connection to wine. So originally barrels were basically made with whatever was regional and what they had the tools to make them out of. So the barrels were actually invented by the Celts. 1000 to 500 BC is roughly when they're estimated. And they actually started out as buckets that they then somehow figured out how to put together. And then that became the first barrel. And so barrel usage became pretty common around 0 AD. And it's documented pretty widely used by the Romans between the 3rd and 2nd century BC. So originally softwoods were used for barrels. It's guessed at that that's just because they didn't have the sufficient tools to work with harder woods. And then as they developed those, they were able to work with more hardwoods like oak and other woods that were common. So the other interesting thing about barrel usage is we sort of take for granted our use of oak today, that's what we've been doing because oak's the best. But there's sort of this sliding timeline of barrel usage from it being this economic transport vehicle to people realizing, wait a second, this is something that actually imparts like an interesting flavor. And that's not really well documented. There's nothing in historical record that says, ooh, this is suddenly when barrels started, like we realized that these are imparting some delicious flavor. However, in the US, oak dominance is actually pretty recent. It didn't start until after World War II. Not widely used really until the 50s and 60s in California. And that was just because the cost of aging, especially with barrels, was so expensive. So before that, the market in the United States couldn't support the cost of aging with barrels. And that also, interestingly, sort of correlated with the rise of research with UC Davis on that as well. And that began with a group of amateur winemakers in California, Martin Ray specifically. And he was basically focused on showcasing the possibilities of California wine. And there was a group of other amateur winemakers, and they were using French oak. So that's sort of like the background for oak usage, sort of like worldwide, and then also in the US, which is much more recent. Sorry, I've got slides on my computer, which are not synced with this. So you guys may already know this, like, why do we use oak specifically? Like, why is it so popular? So there's two reasons. So the wood structure itself. So, and then also the specific chemistry of oak, which is rather unique compared to other species that barrels have been made from. So oak basically is strong, but it's also flexible. And it has what's called tyloses, which help with basically making it a watertight vessel when you put it all together. So structurally, those are the main reasons that oak is so popular. You can make it into a watertight vessel. It's flexible enough to bend the staves, so it can be basically made from one piece of wood. And then you also have the wood chemistry. So basically, when you toast oak, it creates specific flavors. And there's also unique, what we call, like, say, extractives. They're in oak that aren't in other woods that we'll talk more about later. And the other aspect of the structure that is not unique to oak, but is sort of in the sweet spot, is its permeability. So wood is a permeable substance. Water can move through it, air can move through it, and oak is sort of in that sweet spot. So just enough air can move through the oak to get the micro-oxidation to give us the wines that we like. Not too much, not too little. And those are sort of the reasons that oak has become, and it's also really durable. And those are sort of the reasons that oak has become so popular and so pervasive today for aging wine, spirits. All right, so you may or may not know this. There are some issues with what we're talking about, white oak, not French oak, although they may also be applicable. So Quercus alba, which is American white oak, is actually in decline right now. So this has been going on for a while. Basically, our usage of white oak isn't sustainable. We're using a lot of it, and it also takes a really long time for oak to grow to a size that is efficient and feasible to be used for barrels. So typically 100 to 150 years, give or take a couple decades. It's a keystone species. So basically it's really important for ecosystems and wildlife due to, like, the acorns that it produces, which are a big food source for a lot of stuff. So basically it has a disproportionate impact on the ecosystem around it. And the United States has basically had a declining population since the settlers have been here. We've been using it, we haven't been replacing it. So it's kind of an issue. So this problem right here has sort of been the impetus for the research that we've been working on. Basically, high quality oak is really hard to source. There's not enough of it. Everyone wants it, not just for barrels, for furniture, for floors. It's beautiful wood. It's durable. It has a wide range of uses. So due to this, we've been looking at a couple different angles. Okay, so high quality white oak is in demand. What can we do about that? There's not enough of it. Okay, so there's kind of two angles you can look at. So there's what's called adjunct formats. There's like a lot of different words for these, but I'm just going to use adjunct to be consistent through the lecture so you guys know what I'm talking about. So that's basically anything but a barrel. So cubes, staves, sawdust, anything that's in a smaller format than a barrel that you can put into another vessel that's going to impart wood characteristics. So you're going to get an extraction from it, but it's not going to be a barrel. You could put it in a barrel, but it's going to be a smaller format. And then the other angle we're looking at is, okay, are there other wood species out there that can be used for aging? So maybe they're not going to be identical to oak, but maybe they'll give other interesting flavor characteristics that we can use, especially with the wide range of cultivars that we're growing in New York State, that some of them we still don't exactly know what to do with So basically, our our research is focused on using adjuncts, both from an ecological perspective, but also because it's a lot easier to work with at a small scale, and alternative wood species in addition to oak. Okay. So how are we looking at these? So we're using sensory analysis combined with chemical analysis. So we want to be able to describe what these flavors are, what are people sensing, and then we also want to be able to explain why. So we're looking at the sensory analysis, how do people perceive it? And then we're doing chemistry on, right now we're focused on volatiles and aromas, which is what this talk is going to be about. Even though you guys did a mouthfeel tasting. And then basically, okay, looking at the differences in the chemical characteristics, how do those vary between them? What's responsible for those? What might be responsible for those? Okay, so in case you didn't figure it out, today was a sensory tasting. It's going to be for Megan's project. So today we looked at 4 different species, and you guys evaluated the mouthfeel. So we looked at New York white oak, acacia, black cherry, sugar maple. And these are all sourced from New York wood. These are all air dried. Well, according to the people that I sourced them from, they're all air dried. And these were from the original wood that we had, which was a 200°C toasting. They were cut into 1/2-inch cubes. They're aged for 8 weeks. And this was roughly to approximate the surface area of a barrel. And this is the wine that we used. Although we used a 2020 and we had some issues with it, which is kind of the reason we had to switch today to the mouthfeel tasting. So we're going to basically go through each of these wood species today, talk about how they're being used, kind of the chemistry that we know of, and then some results that we got from our original study. And we're going to start with oak and use that sort of as our baseline. And so we're going to go a little bit more in depth into the oak flavor chemistry first. Okay, so right now, white oak in the United States, Quercus alba, is sourced from 2 main regions. These are like the high quality regions. So Ozark region, mainly Missouri, and then also basically around that Great Appalachian Valley, a lot of it in Pennsylvania. Some other places that white oak is sourced, probably more for the spirits industry versus the wine, would be like Kentucky, Tennessee, anywhere that you've got like major distilleries and cooperage operations. All right. Click. So the cool thing is, and I didn't know this until I started working on this project, is there's already cooperages that are using New York sourced white oak to make barrels. From talking to them, I found out that it's actually kind of hard to actually find New York oak. It's sort of as it comes up, they'll take it and make stuff out of it, which is kind of why we're here talking today. So Adirondack Barrel Cooperage, and they actually make full-size wine barrels, and they're able to help us by giving us some samples. And then Quercus Cooperage, which they make kind of a variety of stuff, and they're artisan, and their stuff is sourced more down from the Hudson Valley, Catskills, I'm sorry. Oh, excuse me. Okay. So the first thing we're going to just touch on with oak is, I mentioned earlier, oak is pretty different from most other wood species when we're talking about extraction chemistry. And by that, I mean, what's coming out of the wood into the wine that makes it different when you look at it from a chemical perspective. So for oak, there's 2 main things that sort of stand out as unique. Other woods don't have it except for chestnut. But again, chestnut's a wood you're going to have a really hard time finding because it's pretty much non-existent. So whiskey lactones, some of you guys may be familiar with that. That's kind of like the unique aroma compounds that you smell when you smell oak. So it's like your coconut, vanilla, that stuff. And then we have elagitannins. And these are unique to oak. And I included them because of that. However, the amount that they necessarily contribute to taste, according to academic research, it's not that much. People in industry may have different perspectives on that based on their experience. But it is shown to contribute a small amount. So basically to bitterness and astringency, which are mouthfeel characteristics. So now that we've kind of touched on what's unique about oak, we're going to talk about sort of what happens when oak is toasted and how that contributes to basically the aromas and the flavors that you're perceiving. So when you have a barrel, it's made out of heartwood, and that's the center part of the tree. That's the wood. So in that heartwood, you have a few different components. So there's lignin, there's hemicellulose, there's cellulose, and there's what's called extractives. So those are basically just things that are going to come out of the wood when it's put into a solution. So lignin is responsible for most of the flavor compounds that you guys are going to attribute with aging products besides lactones. So there's two types of lignin, and you're going to get kind of two different types of characteristics from that lignin when they break down during toasting. So you've got like your smoky kind of burned wood characteristic that you'll get maybe more of at like higher temperatures. And then you also get sort of that more spicy clove, vanilla, those sort of characteristics from the G lignin products. So between like the lactones and the lignin, those are going to contribute to a lot of the direct aroma impacts that you get. And that's going to vary so much based on the toasting regime. And that could be like a whole presentation unto itself. So we're not going to really go into that. But the other main product are going to be your hemicellulose products. And so those are your sugars. And those have a more indirect effect. So basically, those are going to result in less fruitiness and more oakiness or like wood characteristics. They don't have like a direct effect, but when they're present, they tend to sort of repress or exacerbate certain other characteristics that are already present. And so there's a compound that I'm interested in that's really not talked about much in literature. McCarran geoside E. I have no idea if I pronounced that correctly. Hopefully I did. So there's, with some aged wines, there's some tobacco characteristics. And this hasn't been explored that much, but this is a compound that breaks down at a higher toasting temperature. And it breaks down into a few different compounds that all sort of have these tobacco-y characteristics. So this is something I'm sort of going more into with my research, just as I'm looking at this. I just wanted to include it because I think it's interesting. And then before we jump to the next slide, so basically these compounds are all going to break down at a different range of temperatures too, which is another reason why the toasting has such an impact on them. So lignin has a really broad range of temperatures that it breaks down at 180 to 900 degrees Celsius. Hemicellulose is going to have a smaller range, 200 to 380 degrees Celsius roughly. And then the McCarran geoside E breaks down at 230 degrees Celsius roughly. Okay. Double select. All right. So this is the last on oak flavor before we just talk about our sensory study. So these up here are going to be contributing to taste. So when I say taste, I'm talking about sweet, sour, bitter, salty, umami. So we've got coumarins, lignans, not lignin, and triterpenoids. And so these are more recent research. So coumarins and lignans both contribute more to bitter perception. And coumarins are also a compound that's greatly affected during the seasoning process of oak. So they break down, and that's why a lot of times you'll see people talk about during seasoning, oh, it's less bitter after it goes through the seasoning process, because these are breaking down and some of the tannins are also washing out. Let's see, let me look at my notes real quick. So lignans, they've also done a more recent study where they added these to a wine and increased the bitter perception when they're in a group. So this is just information for you about some of the stuff that can affect flavor when you're aging with wood. It's pretty complex. There's a lot to it. And these are some of the main compounds that can affect that. Triterpenoids are a new one too. These can affect bitterness, but they can also impact sweetness and sourness as well. Those haven't been widely studied. Okay, so before I go to the next slide. All right, so I'm going to tell you guys which one was the oak. So 645 was the New York oak. You guys are curious. And does anyone want to share any of their mouthfeel descriptors? Anything stand out to you? Like most intense? Cool. Anyone else? Yeah. Cool. Yeah, they found, okay. Oh, people have found tobacco smells. Yeah, they have found those isomers of the tobacco smell in oak aged products and in oak, so that's not too surprising. All right, so now I'm going to talk to you guys just a little bit about some of the results we got from our sensory study we did last year. I don't know if there's anyone in here that participated. But basically we had Finger Lakes winemakers come up to Agritech, and they did a study over the course of 4 weeks. And this is using the same samples, but they were in a sawdust format, and it was aged for 3 weeks. And they did mouthfeel, aroma. And so some of the results for the New York 200 degrees Celsius, which is the sample you guys tasted today, you can see up there floral, fruity, pastry were the most widely chosen, about 50% by the panelists. And then nutty, buttery, spicy. And then I included just the other treatment, because that one was significantly different compared to the 200 degrees Celsius. And you can see there's some very different descriptors: wood, toasted, smoky. And those are all compared to the control, which is fruity and floral, nutty. All right. So now we're going to go on to our second wood, acacia. You guys are probably familiar with this, just not necessarily as a barrel. Some of you may be. These are more commonly used for untreated wood posts. It's a really durable wood. It's really hard too if you've ever tried to cut it for firewood. But it's also been used for barrels for a decently long time. It's more popular in Europe, but it's also kind of gaining popularity in California. It's used for whites from what I've seen typically. And so some of the like anecdotal commentary is sort of like it contributes a texture. It's kind of a floral attributes, citrusy, less of the like wood and spiciness. So it's more subtle. And this is native to the United States. Some wines it's been used with Sauvignon Blanc, Chenin Blanc, Viognier. And it's also been used historically to age sherry. I'll tell you in a couple slides. Don't want to ruin the surprise. Okay. So here's a summary of just some of the differences between oak and acacia from a chemistry point of view, what we know. So the big differences are no allagitannins. So that's probably that difference in mouthfeel. And then from an aroma standpoint, there's pretty much no eugenol, and that's a lignin derivative. So that's one of the things that pops up once we do the toasting. And then it also has some unique compounds, and those are what we call the marker compounds. There's not really much literature about if they contribute anything from a sensory perspective. It still hasn't been studied that much, especially compared to oak. But if you ever want to identify a wine that's been aged with acacia, that's how you would know. Okay, so drum roll. The acacia is 904. It was worse than that. But it was almost yeah, that's why it was a mouthfeel only tasting. No, it's okay. It's okay. It was a yeah. Does anyone have any mouthfeel characteristics they want to share? Besides bad cherry. All right. Yep. Okay. That's a mouthfeel characteristic. Nice. Cooling. Sorry for our Zoom audience. Need to work on that. Okay. So from our 2022 sensory study, these were the aroma descriptors we got. Again, this one was only aged for 3 weeks with sawdust, which, you know, it's a greater surface area, so you're going to get a different extraction chemistry. So we got buttery was pretty much like the predominant, and then less common was like a nutty, toasted, or coconut. Okay, and I think I forgot to mention this. So these were aged at a rate of 3 grams a liter, which is sort of like a commercial industry standard rate. So we were trying to get an accurate view of that. All right, so on to our next wood. Black cherry. All right, So we're actually going to talk about two cherry woods here. So the black cherry, the Prunus serratina that's native to North America is what you guys tasted today. But I'm mostly going to talk about European cherry because there hasn't been any research yet on American cherry except for what we've done. So cherry is pretty much used for cabinet, furniture. It really hasn't been studied for aging wine, the American variety. The berries are also medicinal, used for flavoring. So we're going to mostly talk about European cherry because that's what we have research on. So this research group has done a bunch of work on alternative woods. If you guys are interested in looking more about that, especially European cherry, which is Prunus avium, and that's a European native, although it grows here, I think, as an ornamental tree. So here I just pulled up some notes for more of examples of commercial usage because European cherry is in use commercially in limited amounts. Historically, it has been used more, although lately, like in the last 20 to 30 years, oak has been predominant. So from the article here, basically they talk about it's generally used for larger format aging, a couple different styles, Amarone, also for red blends. So let's see, any other notes? And you can see some of the flavor notes up there. So like maraschino cherry, cocoa bean, sweet spice, balsamic, wet peach. So sort of the overall consensus is basically cherry has some unique flavors. It also can be a bit oxidative. So some of the winemakers use it in conjunction with oak or for shorter time periods, but it's with a very specific style in mind, but it can give very interesting aroma notes when it's used properly. Not trying to duplicate oak usage, but come up with its own character and style, which is sort of the whole point of these alternative woods. So we're going to talk about the chemistry differences of the European cherry. So basically the major differences are there's more lignin derivatives. So we talked about earlier, lignin is one of the parts of the heartwood that when you toast it, that gives you most of the character that's contributing. So these are just going to be more intense, higher concentrations. Lower hemicellulose derivatives. So those are sort of the more indirect characteristics. They're going to basically be suppressing fruitiness or enhancing oakiness. And then, as you can see from some of the flavor descriptors, there are definitely some unique compounds that are contributing to different flavors. Cherry has a bunch of unique compounds. I didn't list them because honestly, it's a little bit boring, but there's different stuff going on there. And then the last part is, or cherry is basically more porous. It's more oxidative. You're getting more airflow in there. So you need to be aware of that if that's something you're looking at using. All right. So the American cherry that you guys tasted is 735. Did anyone have any strong mouthfeel attribute that came out to them? Stood out? Okay. Cool. Painfully bitter. Anyone else? Okay, cool. Oiliness in the mid palate. Anyone else? Good to know. Okay, so from our sensory study, the aroma characteristics predominantly nutty, and then some sort of more subtle, less predominant. You can see there's like a wider range. So caramel, cedar, coconut, floral, pastry, vanilla. And you can see that sort of might fit in with some of the descriptors they got for the European cherry. All right. So our last wood species is going to be sugar maple. I think everyone here is familiar with that, probably from a maple perspective, maple syrup. It's also used for wood products. And actually, it's also been used commercially for aging spirits, which is interesting. So mostly bourbon. Woodford Reserve is one, and then there's another one listed on there as an example. So frowny face because there's nothing to really share with you guys about wine chemistry because we haven't finished our analyses yet. But it's also a happy face because hopefully we'll have something interesting to share with you the next time we see you about what may be different or interesting about sugar maple chemistry, especially since it's already being used commercially to some extent. So that's something we're working on right now, literally as we speak. So that's going to bring us to our last slide for sugar maple. So that's going to be 197. Did anyone have any attributes that stood out to them? Thinnest? Okay, thin mouthfeel. Good to know. Anyone else? Sweet. All right, so from our study, sugar maple was fruity and then had some toasted wood and floral aspects. So not much there, but yeah. So now we're going to basically, what we're going to do is we're going to summarize what we talked about. And then I'm just going to briefly talk about what we're sort of working on now, and that'll pretty much wrap up our presentation. So this is basically just a chart of sort of a summary of the main chemistry differences between oak and other species. So as we talked about, lactones and elagitannins, not earth shattering. We don't know anything about black cherry or sugar maple yet, so. And see, these are some more of the chemistry differences. These are basically the quantitative ones. So nothing's missing. It's just they may be different in present in different amounts. And then there's also some of the aroma notes from industry. Those aren't from academic studies, but those are some of the notes from some of the interviews and stuff. In addition, just to give you an idea of sort of what may be possible. I'm not going to read through those, so it'll be recorded if you want to go back and look at it. And so again, this is just kind of a summary slide of some of the current varietals that are being produced with acacia and European cherry. So to give you kind of an idea of some of the grapes it might work well with. Some of these might be applicable, some of them not, but that's what we got. And then to sort of round out our summary of what we talked about today. So one of the big questions we're looking at is, are they different? And then how are they different? So this is actually a chart from one of the research groups that I mentioned earlier. And so this is comparing a Syrah that was aged for 12 months in a barrel at one toasting level. And so you can kind of see there's some differences here in like the overall profile in some of the different characteristics. So like spicy, vanilla, toastiness, just depending on what you're looking at. So basically it just gives you an idea that there's different profiles depending on what you're trying to do. All right, so now I'm just going to talk briefly about sort of what we are working on next. So we sort of did our initial study doing a flavor characterization, looking at the differences between wine aged with various woods. And we're also doing the chemical analysis. And now we're sort of looking to the next phase of our project, and we're sort of looking at it from two angles. So one is going to be sort of the commercial consumer side. So, okay, we have these woods. Does anyone actually want to make something with them, and do they want to drink it? Because that's a very different question than saying, okay, this is what's different about them from a chemistry view, but does anyone actually care? So there's not a lot of, and then, so this is both from not the wood species side, but also from an adjunct product side. So my initial impression is there is definitely some stigma in industry about using adjunct products. If you guys get a chance to like stop by and talk about it or take the survey that I had up earlier, that'd be great. We're just trying to get some more information about that. So the other side we're looking at is sort of the adjunct wood product chemistry. So there aren't really any comprehensive studies that look at adjunct wood products or wood species across different varietals, and also consumer preference. So can we still make a wine that customers like using adjunct products and alternative woods? I don't know. That's what I'm sort of hoping to talk to you guys about and find out more. So the second angle we're looking at is, again, more related to the adjunct wood product industry. So I have been talking to some cooperages, mills, basically on that side of things. And from what I found out, basically everyone uses what's called timber standards. That's what they use for barrels. So they use what's called, if anyone's ever worked like as a carpenter or has any familiarity with that. So there's different grades of wood, right? So you got like common, you've got first, second. It's basically based on how much clear wood there is, how much wood you're going to actually get out of a cut that doesn't have any knots or other defects. And so that's actually what the timber industry, that's what the mill industry uses for grading barrels. So there's not any chemical standards for the most part, or that they're broadcasting that they're using. Even less so when you're looking at adjunct products. So we're sort of looking at, okay, are there parameters that we can define, and can we use trees that would not be classed as suitable for barrels, bring it back to like that ecological, there's not enough white oak to go around. So there's a whole lot of white oak, I bet, that you can find in your firewood. Would that be good for adjunct wood? I don't know. So that's sort of the other angle that we're looking at, is like what's important to ensure sensory quality when you're actually processing and making the product for aging. So we're looking at the consumer side and then actually making the products, what matters. All right. So now I'm just going to wrap up with some acknowledgements and sort of our plug at the end. So there's a lot of people and groups to thank. So I would like to thank the Climate and Applied Forest Research Institute of CAFRE. We're working with SUNY ESF on this project, and they're responsible, the CAFRE is responsible for our funding for this. Julie Suarez, who's been instrumental in helping us secure funding for the master's project as well as continuing for this. And Dr. Peter Smallage, who actually brought this project to us, and he's from the ecological forestry side. Dr. Christophe Duplay, who's been helping us with our chemical analysis, and of course the Cornell Craft Beverage Institute. Let's see if I can name you guys. Anna Catherine, Chris, Molly, Luann, Pam, Courtney, Hannah, thank you. I saw the face. They've all helped so much, whether it's helping me find things in the lab that I can't find, helping me set up sensory, helping me with questions, listening to me present. The list goes on, including today, helping us get set up. And then also our wood donors, so Adirondack Barrel Cooperage, Eric Randall, Fred Siegel, Black Locust Mill. And then thank you to Anna Catherine and Chris for helping me, give me the opportunity to present today and practice and share this information with you guys, and also for putting all the work into for Bev. Okay, so our last slide. If you guys have some free time, I would love to talk to you about how you use wood in your aging programs. If you're a producer or you have been, why or why not do you use adjunct products, or have you not used them? So I'll be at the Idea Cafe Thursday, and I'll also be here all 3 days. I also have an email that you can email me at jml248@Cornell. And then our last plug is from Megan. So thank you for introducing me, Megan. And Megan, I think she already said this. She is looking for wine or cider employment in the Finger Lakes, and you can get her info from there. That's her LinkedIn. So that's the end of it. Does anyone have any questions?
Okay, I'm going to pass microphone so that people on Zoom can hear you when you ask your question.
And anyone on Zoom, you can put your questions into the Q&A and I'll read them to Jen.
I have two questions. One is, why did you use Pinot Grigio?
That's a great question. I had that in my notes originally to talk about. So the first run through we did, we were having a lot of issues with taste interference from it being too sweet or too sour. And so the other aspect is basically what is something that we can easily procure from the liquor store. So those are pretty much the two main reasons, and also what's not oaked. So those are pretty much the driving factors.
My second question is the adjunct products, when they're toasted, what do they come to the same temperatures that you do a barrel at, or they are lower temperatures?
That's a loaded, complex question. So first, I'll just preface that with saying, depending on where you're getting your barrels done, they may or may not actually know what temperature they're toasting at. So that's the first point. The second point is, depending on the toasting method, that's going to change the profile of the toasting itself. So there's open wood fire, which is traditional. You've got radiant heating, you've got convection heating, and all those basically are going to change what sides of the product have a toast on it, how far the toast goes. It also depends on, are you toasting your adjunct product in its adjunct product form, or are you toasting it in a stave form? So wait, did that answer your question? What was the question? Sorry.
I just was wondering how much it really replicates the toast of a barrel.
So not really. I mean, yes and no. You can't really, unless you actually have a method to
Chop up the barrel.
Yeah, like you'd have to basically, from a scientific perspective, you'd have to actually have a way to precisely toast a barrel to compare it to, because there's too much variation with a lot of traditional toasting methods, unless you have like a precision facility. But even then, not really, because usually you're toasting from one side for a barrel. So.
We have a question from Zoom, which is, what sort of price variation could one expect when looking at alternate wood species for cooperage? I imagine Q alba would be the most expensive option, but how do the less commercially visible species compare?
That's a great question. So that would partially go back to what I was saying earlier about depending on the grade that you're sourcing. So grading and availability. So higher grade is always going to be significantly more expensive. So just to give you an example for oak, if you're looking for like first and seconds logs, you're looking at like on the high end in New York, I think the stumpage prices were like $1,500 a log. Whereas for firewood, you're looking at like $2 a face cord. So a face cord is 4 by 18 by 8. So it's like, so significantly, as far as other species go, usually they're going to be less than oak. I can't give you a specific number though, if that's what you're looking for. I do know acacia is also in demand though, from when I was talking to the Black Locust company. They were having to source from out of state because they had so much demand, because it's such a durable wood that's useful for outdoors. So yeah,